2212 Lab 4 by Connor Wynn. Introduction. The purpose, methods, and results. The purpose of this experiment is to measure the effects of distance on the magnetic field of a bar magnet and then to create a computational model of that magnet. Methods. We measured the strength of the magnetic field at various locations of the magnetometer, and then we created a computational model of the magnet. Results. Experimental model and a computational model reflected each other. Principles. Biot-Savart law and the dipole magnetic field. The Biot-Savart law is, as you can see, it's the integral of the length segment times radial direction divided by distance squared and times the constant. Now, the dipole magnetic field is just kr to the power of n. Now, the model. The system for this experiment is the phone, or specifically the magnetometer in the device. The surroundings are the bar magnet and the Earth magnetic field. The forces for consideration is we're considering the magnetic field from the magnet itself and the magnetic field from the Earth. Experiment. Finding the magnetic field. Now, we compensated the phone to find the magnetic north by zeroing the x-axis on the app. And then we found a magnetometer chip on the phone via the app and tape, as demonstrated in the figure below. Now, after that, we measured the distance from the chip where the magnetic field strength of the x component was 20, 70, 120, 170, and 220 UT. Now, and the y field for these values should have been constant. Now, this is the data from the experiment. As you can see, ln bx versus ln r, the slope was negative 2.959 feet. And we can see the average of ln r and average of ln bx. And on the off-axis field, these are the measurements found below. Now, experiment observations. When the magnetometer is far away from the magnet, it measured a near zero magnetic field in the x direction. And as a magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Now, coding. Now, we defined the magnet and the mu hat in coding, and we plugged in what the magnitude of magnetic moment is. And then we defined a dipole of the magnetic field with the r mag and r hat. And then we found the distance and scaling. Now, for the axes, we had to find the observed axis minus the magnetic position, and then calculate a dipole of the magnetic field, which is magnetic dot mu, and the axis. And we did it for the various data points below. And we also had to represent the magnetic field 45 degrees from the axis, which we did from the observed 45 degrees for the dipole of magnetic field. Now, this is the results. Now, the calculated magnetic field was 3.58 times 10 to the negative fifth on the x, and then 1.07 to the power negative 4, 0. Now, the experimental magnetic field was 6 times 10 to the power negative 5, 2 times 10 to the power negative 5, and 3.28 times 10 to the power negative 5. Now, the values from the experiment and the coding follow the same unit vector and sign, but the scale is off along the 45-degree angle from the axis. Now, the errors in this experiment were that the measurements could have been off in determining the magnetometer with the tapes, and app issues with the phones, because we had to switch phones. Now, what if the phone was not compensated for the magnetic north? Then that would have meant that the x component would have been different. And if we did not calibrate for the other compensations, then the whole net magnetic field would have been different. And if we used two mags instead of one, we would have a different magnitude because we would have to calculate a larger magnetic field instead of a smaller magnetic. Thank you.